To improve chances of passing the electrical contractor exam, concentrate efforts on thoroughly understanding the codes incorporated into the exam. The codes relevant to the exam that would be beneficial to study are NFPA 70, NFPA 72, NFPA 78, NFPA 101, NFPA 13, and NFPA 14. One needs to be sure to know when each of these codes changed and what specific changes occurred with the revisions. Mastering this aspect of the code makes the math-related portions of the exam significantly easier to navigate. Firstly, focus on NFPA 70, which is the National Electrical Code. This is the cornerstone of electrical safety and the basis for most electrical installations. Understand its structure, how it's organized, and how to quickly find information within it. Secondly, turn to NFPA 72, the National Fire Alarm and Signaling Code. This covers fire alarm systems, signaling systems, and emergency communication systems. Be familiar with the requirements for installation, testing, inspection, and maintenance of these systems. Thirdly, look at NFPA 78, which covers the National Electrical Safety Code. This deals with safety requirements for electric supply and communication lines, equipment, and associated work practices. This code addresses safety concerns related to utilities and high-voltage systems. Fourthly, concentrate on NFPA 101, the Life Safety Code. This code addresses life safety requirements in buildings and structures, focusing on egress, fire protection, and other measures to protect occupants. It is crucial to understand how this code interacts with electrical systems, ensuring overall safety. Fifthly, study NFPA 13, the standard for the installation of sprinkler systems. This covers the design, installation, and maintenance of automatic sprinkler systems. While it may seem unrelated, electrical systems often interact with sprinkler systems, particularly in fire alarm and suppression systems. Sixthly, investigate NFPA 14, the standard for the installation of standpipe and hose systems. Similar to NFPA 13, this covers the design, installation, and maintenance of standpipe and hose systems for fire suppression. Knowledge of these systems is valuable in understanding the broader context of fire protection in buildings. When studying these codes, one should focus on the following. Firstly, code structure and organization. Familiarize yourself with how each code is organized. Understand the chapter structure, article designations, and section numbering. This will enable you to quickly locate specific information during the exam. Secondly, key definition. Pay close attention to definitions of terms used in the codes. Understanding the precise meaning of these terms is essential for accurate interpretation of code requirements. Thirdly, scope and application. Know the scope and application of each code. Understand what types of electrical installations or systems are covered by each code, and what types are excluded. Fourthly, installation requirements. Study the specific requirements for installing electrical systems and equipment. This includes conductor sizing, overcurrent protection, grounding, wiring methods, and equipment clearances. Fifthly, testing and inspection. Understand the procedures for testing and inspecting electrical systems to ensure compliance with code requirements. This includes visual inspections, electrical testing, and documentation requirements. Sixthly, common calculations. Practice common electrical calculations related to conductor sizing, voltage drop, overcurrent protection, and equipment grounding. Be prepared to apply these calculations in exam questions. Seventhly, revisions and updates. Stay current with the latest revisions and updates to the codes. The electrical industry is constantly evolving, and code requirements may change over time. It's important to be aware of these changes and how they affect electrical installations. Eighthly, practice questions. Work through practice questions and sample exams to test your knowledge and identify areas where you need to improve. This will help you build confidence and prepare for the actual exam. Ninthly, code interactions. Understand how the different codes interact with each other. Electrical installations often involve multiple codes, and it's important to understand how these codes work together to ensure safety and compliance. Tenthly, real-world applications. Relate the code requirements to real-world electrical installations. This will help you understand the practical implications of the codes and how they apply in everyday situations. Focusing on these areas will provide a solid foundation for success in the electrical contractor exam. When approaching math problems, remember these common principles. Ohm's law is the fundamental relationship between voltage, current, and resistance. The formula is voltage equals current times resistance, or volts equals amps x ohms. This law is essential for calculating voltage drop, current flow, and resistance in electrical circuits. Power calculations involve determining the amount of electrical power consumed by a circuit or device. The formula for power is power equals voltage times current, or watts equals volts x amps. For three-phase circuits, the formula is adjusted to account for the phase relationship. Conductor sizing requires determining the appropriate size of conductors for carrying electrical current. The National Electrical Code, or NEC, provides tables and guidelines for conductor sizing based on ampacity, temperature ratings, and other factors. Voltage drop calculations are used to determine the amount of voltage lost in a circuit due to the resistance of the conductors. The NEC provides guidelines for limiting voltage drop to ensure proper operation of equipment. Short circuit calculations are performed to determine the magnitude of fault current that can flow in a circuit during a short circuit condition. This information is used to select appropriate overcurrent protection devices. Grounding calculations involve determining the appropriate size of grounding conductors and equipment grounding conductors to provide a safe path for fault current to return to the source. Transformer calculations are used to determine the voltage, current, and power relationships in transformers. This includes calculating the turns ratio, voltage transformation, and current transformation. Motor calculations involve determining the voltage, current, and power requirements for electric motors. This includes calculating the full load current, starting current, and horsepower rating. Conduit fill calculations are used to determine the maximum number of conductors that can be installed in a conduit or raceway. The NEC provides tables and guidelines for conduit fill based on the size of the conductors and the type of conduit. Box fill calculations are used to determine the maximum number of conductors, devices, and equipment that can be installed in an electrical box. The NEC provides guidelines for box fill based on the size of the box and the type of devices. To further elaborate on these calculations, let's delve deeper into each area. Firstly, with Ohm's law, understand how to manipulate the formula to solve for voltage, current, or resistance, given the other two values. This is the cornerstone of circuit analysis. Secondly, consider power calculations. In addition to the basic formula, understand how to calculate power in both direct current, or DC, and alternating current, or AC circuits. For AC circuits, power factor comes into play, affecting the real power consumed. Thirdly, conductor sizing is a crucial skill. Refer to NEC Table 310.16 to determine the ampacity of conductors based on their size and insulation type. Account for ambient temperature correction factors and conductor dating factors when multiple conductors are bundled together. Fourthly, voltage drop calculations help to ensure that the voltage at the end of a circuit remains within acceptable limits. Use the voltage drop formula and the NEC guidelines to calculate voltage drop and select conductors that minimize voltage loss. Fifthly, short circuit calculations are essential for safety. Calculate the available fault current at various points in the electrical system to ensure that overcurrent protection devices can safely interrupt fault currents. Sixthly, grounding calculations. Understand the difference between equipment grounding conductors, or EGs, and grounding electrode conductors, or GECs. Use the NEC tables to size grounding conductors based on the size of the overcurrent protection device. Seventhly, transformer calculations. Calculate the voltage and current ratios in transformers using the turns ratio formula. Understand how transformers affect impedance and fault current levels in electrical systems. Eighthly, motor calculations. Determine the full load current, starting current, and branch circuit protection requirements for electric motors. Refer to the NEC tables and guidelines for motor circuit calculations. Ninthly, conduit fill calculations. Use the NEC tables to determine the maximum number of conductors allowed in a conduit based on the size of the conductors and the type of conduit. Account for conductor fill dilating factors when multiple conductors are installed in a conduit. Tenthly, box fill calculations. Follow the NEC guidelines for box fill to ensure that electrical boxes are not overcrowded with conductors, devices, and equipment. Overcrowded boxes can lead to overheating and potential safety hazards. Regarding NFPA 70, also known as the National Electrical Code, it is the cornerstone of electrical safety in the United States. Published by the National Fire Protection Association, or NFPA, this code establishes the standards for safe electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and industry best practices. Understanding the NEC is essential for anyone working in the electrical industry. It provides the guidelines and requirements for ensuring that electrical systems are installed and maintained safely. The NEC is organized into chapters, articles, and sections, each covering a specific aspect of electrical installations. It includes detailed information on conductor sizing, overcurrent protection, grounding, wiring methods, and equipment installation. The NEC also addresses special occupancies, such as hazardous locations, healthcare facilities, and swimming pools, which have unique electrical requirements. In addition to technical requirements, the NEC also includes administrative provisions that govern the enforcement and interpretation of the code. These provisions address issues such as permitting, inspections, and qualifications of electrical workers. The NEC is widely adopted by state and local jurisdictions in the United States, and it is often incorporated into building codes and regulations. Compliance with the NEC is essential for ensuring the safety of people and property from electrical hazards. One must be able to quickly locate information within it. To effectively navigate the NEC, familiarize yourself with its structure, including the chapter structure, article designations, and section numbering. Use the index to quickly locate specific topics or keywords. Pay attention to definitions of terms used in the code, as these are essential for accurate interpretation. When studying the NEC, focus on the sections that are most relevant to your work. This may include chapters on wiring methods, overcurrent protection, grounding, and equipment installation. Work through practice questions and sample exams to test your knowledge and identify areas where you need to improve. Stay current with the latest revisions and updates to the NEC by attending training courses and subscribing to industry publications. When applying the NEC in the field, always follow the code requirements and consult with qualified professionals if you have any questions or concerns. Remember, the NEC is intended to protect people and property from electrical hazards, so it's essential to take it seriously. With dedication and hard work, passing the electrical contractor exam in March is achievable.